This is a short video for running a t-test to determine statistical analysis in Excel. I'm going to start by introducing my research. So along the side here we have the dependent variables, i.e. the variables that we're going to measure, and across the top we have the independent variables, the variables that we're going to change. So there are a lot of variables. I won't go through them all because we're only going to be looking at one in particular, and that is the maximum ground reaction force in the medial lateral direction. Now this research is looking at two particular sidestepping manoeuvres that an assistant referee performs during a football match. The first manoeuvre is a sidestepping manoeuvre where the participants start in one position, sidestep all the way across the force plate and finish in the second position. The sidestepping change, the participants start in the initial position, sidestep until they contact the force plate, and then change direction, sidestepping back to the start. For both manoeuvres, we're going to be collecting data moving in the left direction and the right, and also for each of those combinations, collecting data from the leading leg and the trailing leg using the force plate. As a control, we're also collecting data from straight line running trials. So this is some data which I've collected from my pilot study so far. Two important things to point out here. Although I said we were collecting data moving left and moving right, for this demonstration we only have data moving in the right hand direction. It just makes it slightly easier to explain when it comes to the comparisons. And secondly, when I come to analyse my final results, I will no doubt be using a one-way or even two-way ANOVA using the SPSS statistical analysis package. But for this demonstration I'm using a t-test. Now unfortunately a t-test only allows you to compare multiple means with multiple means. It does not allow you to compare only one mean from one variable to another mean from another variable. So what I mean from this is if we were to compare sidestepping, moving right, leading leg data, we have 3 trials for that particular combination. So what I would do there is take an average and then compare that with the average of, say, sidestepping, moving right, trailing leg data, which would mean we'd be comparing one mean with another. Unfortunately, Excel doesn't allow you to do that when you're conducting a t-test. So for the basis of this explanation, we'll assume that each trial represents an average. So when it comes to comparisons, we'll be comparing the 3 trial data for each combination. So on to the comparisons. We're going to do these 3 comparisons down here to establish whether there is statistical significance. So to start with, we have sidestepping, moving right, collecting data from the leading leg. So that's sidestepping, moving right, leading leg. So that's these 3. And then we're comparing that with sidestepping, change, moving right, leading leg. So what I'll do is show you the t-test for each of these 3 comparisons, and then I'll quickly go through the significance or what the data actually shows us. So to do a t-test in Excel, you type equals t-test, open brackets. This is asking you for the first set of data that you're comparing. So as we said, sidestepping, moving right, leading leg, sidestepping, moving right, leading leg. That's these 3 sets of data here. So we highlight those 3, comma, and then this is asking you for the second set of data. So we looked at sidestepping, change, moving right, leading leg. Apologise, it's actually over here. Sorry, sidestepping, change, moving right, leading leg. So it's these 3 trials here. So you type a comma, now it's asking you for whether it's a one-tailed or two-tailed test. So in other words, whether we know which condition is going to be higher than the other. So we're assuming that there's going to be a statistical difference, or we're hoping we might find a statistical difference, but which condition is going to be higher. So if you look at these 3, you can see these are in the 200s, and these are in the 4, 5, 600. So we can already see that if we do find a statistical significance, that the data for sidestepping change is going to be higher than the data for sidestepping. So we don't have to say that we don't know which way the difference will go. We do know which way the difference will go, so it's a one-tailed distribution. Therefore, we just type a 1, followed by comma. And this is asking for what type of t-test we're going to be doing. So a paired t-test is where all the data is from the same participant, which it is. All of this data on this row here is all collected from the same participant. So it is a one-tailed test. So we type in 1. If this was from a different participant to this, then we would do an independent t-test, and it would be one of these two here. We close the brackets and hit enter, and that gives us our statistical significance. So we work with the value of p is less than 0.05. So this is highly significant. Now just quickly do the two t-tests for these two comparisons. So we're looking at sidestep and change, moving right, leading leg, sidestep and change, moving right, leading leg, so that's these three. The second set of data is sidestep and change, moving right, trailing leg, sidestep and change, moving right, trailing leg, so it's these three. Again, it's a one-tailed test, and again, it is a paired t-test. Now, this is even more highly significant. We can actually increase decimal places if we need to. And then the last one we're looking at is sidestepping, moving right, trailing leg, sidestepping, moving right, trailing leg, so that's these three. And the straight line running as our control, so it's these three here. Again, one-tailed and paired t-test. And there we go. So I'll quickly explain now what these three p-values actually mean. So if we look at the first comparison, all we've assessed is the difference in maximum ground reaction force applied in the medial lateral directions, that's along the x-axis, between sidestepping and sidestepping change of direction when the participant is moving right and we're collecting data from the leading leg. So effectively what this means is that there is significantly more force applied when the participant changes direction in the leading leg than when he simply sidesteps all the way across the force plate. Now that makes sense because the participant has to apply force to the ground in order to brake and stop and then change direction and move in the opposite direction. So we would expect that. Hence why it's a strongly significant p-value. The second comparison we're looking at is the difference between the force applied in the leading leg and the trailing leg in the sidestepping change of direction maneuver. So interestingly, when you look at the research between sidestepping and straight line running is what we call a cyclic movement. So both legs do the same thing over and over again, unless you have any kind of severe muscle imbalance or any other kind of imbalance. You would expect the left and right leg to be showing pretty much the same data. Sidestepping is entirely different. It is a completely asymmetrical maneuver whereby the leading leg and the trailing leg are doing effectively different things. So often what you might find is that the leading leg, when sidestepping all the way across, is actually applying a slight braking force, and then when that lifts off the floor, the trailing leg contacts the floor and actually applies the propulsion for the participant to move in the lateral direction. So they're actually doing very, very different roles. And as you can see from this particular movement, the sidestepping change of direction, when it comes to actually changing in that lateral plane, horizontal plane, the leading leg contributes to the force application with the ground significantly more than the trailing leg does. And that is a very, very high significance level of P is less than 0.004. So just looking at this participant alone, we can say that when he changes direction in the sidestepping maneuver, the leading leg applies a lot more force than the trailing leg. And this is important when we're looking at whether he changes direction sidestepping more in one direction or the other, and whether that is causing excessive loads on the knee, ankle, hip, or whatever. So it is important to note those differences between force application in the leading and the trailing leg. Finally, we just looked at the sidestepping moving right trailing leg. So that's this data here, and we compared that to the control. So that's just a simple demonstration that when you're looking at the maximum medial lateral ground reaction force that is applied, there is significantly more simply sidestepping than there is during straight line running. So that is how you conduct a t-test to determine statistical significances in Excel.